Okay, students, welcome. We will go to another topics, thermodynamics of mixing. Very small topics, but I have seen question from these topics in different examinations. There were question in JAM examination, in MSc entrance test of various universities also. Just understanding 2-3 equations will help you to solve these questions. Okay, let us discuss it. Mixing of ideal solution, ideal mixture. We have delta V mixing, we have delta H mixing, we have delta G mixing, and we have delta S mixing. For an ideal solution, this value is 0, this is also 0, this is RP NA ln XA plus RT NA ln XA plus NB ln XB. Okay, this is delta G mixing. Delta X mixing minus R NA ln XA plus NB ln XB. You know why? We know delta G is equal to delta H minus T delta S. Mixing. Therefore, this term is 0. This is RT NA ln XA plus NB ln XB minus T into minus RNA ln XA plus NB ln XB. Minus and minus plus, therefore RP. This is it. Therefore, for an ideal solution, these two terms are 0. For more details, please watch my topic solution. Why delta V mixing and delta H mixing are 0 for an ideal solution. Okay. Now, for only these two equations you have to remember. We will write that equation here. For non-ideal solution, delta G mixing, delta S mixing. Here, it may be delta V may be negative or delta V positive. This is negative deviation, this is positive deviation. Here also, delta H negative or delta H positive. For positive deviation, delta V positive, delta H positive. These two cases are called positive deviation, and these two cases are called negative deviation. Whether it is ideal or non-ideal, you can use this same equation, but sign will change. Same equation, but delta G should be, there should be a negative value, Here it should be a positive value. That's all. Same equation but negative sign and positive sign for non-ideal. Fine. Therefore, we can remember this equation. What is our delta G mixing? Delta G mixing R T Na ln XA plus NP ln XP. Na is the number of moles of component A, NP is the number of moles of component B, XA is the mole fraction of A, XB is the mole fraction of B. This entire value will be negative. Why? Because this is a fraction, this is also a fraction, therefore this value will be negative and this value will also be negative, therefore the entire value will be negative. Delta S mixing, you just remove the T or just remove T, put the minus. All things are okay. Na X ln XA, NB ln XB. This entire value will be negative. Negative into negative will be positive. Therefore, these things will be positive. During the mixing, entropy will increase. During the mixing, free energy will decrease. Therefore, the entire system will be negative, free energy decrease. This entire is positive. Therefore, that's a spontaneous process. That's a spontaneous process. Fine? Okay. Now, let us see some previous questions. If you can remember this equation, that will be very simple. Let us see some previous question. Okay, one question. A container is partitioned. A container is partitioned into two components. One of which contains 2 moles of helium, while the other contains 3 moles of argon. The gases are ideal. The temperature is 300 Kelvin. Pressure 1 bar. Okay. First question. What is the total Gibbs free energy of the two gases? Second, the partition between the compartments is removed and allowed to mix, then what is the delta G mixing? Third, what is the delta H of this process? Delta G mixing of this process. Okay? Yes. Simple question. A container is partitioned into two components. One which contains 2 moles of helium, while other contains 3 moles of argon. Okay? Therefore, you have a container, two containers, container 1 and container 2, helium 2 mole and argon 3 mole. Ideal gas. What is the total Gibbs free energy of two gases when they are separated? For an ideal gas, total free energy of standard free energy of helium, standard free energy of argon at 1 bar and 300 Kelvin. For an ideal gas, this is 0, standard free energy. Okay, arbitrarily fixed, a standard state, because they are at equilibrium. They are at standard free energy, because no change, nothing. They are at equilibrium in the container. It's fixed. Now that's all the first part of the question. Then the partition between the container is removed. You just remove the partition, allow them to mix. What is delta G of mixing? Delta G of mixing is equal to RT N helium ln mole fraction of helium plus N argon ln mole fraction of argon. 8.314 into 300 into 2 into ln 2 by 5. Okay, mole fraction 2 by 5 plus 3 into ln 3 by 5. But ln, you can make 8.314 into 300 into 2 into 2.303 log 2 by 5 plus, or 2, you can take the 2.303 outside, 3 into 2.303 log 3 by 5. Okay? Yes. You will get final answer is minus 8.339 kilojoule. This is the final answer. Now third, what is a delta G mixing? It's an ideal solution. For an ideal solution, delta G mixing is equal to 0. For ideal solution, for ideal gas, delta G mixing is equal to 0. Okay, this is third. Okay, very simple. Remember the equation, that's all. You can solve it. If you don't know the equation, you will be confused how to solve this. Okay, avoid that confusion. Okay, this is only question. All other questions, there are multiple questions in different examinations. All can be solved by these equations. Once again I write the equation here. Delta G mixing is equal to RT NA ln XA plus NB ln XB plus NC ln XB. It goes on, depends upon number of the components. Delta X mixing is equal to minus R Na ln XA plus NB ln XB plus NC ln XC. Okay, simple, very simple. Therefore, only you have to remember the equations. Fine. Okay, let us see the next video. Keep watching, write the notes, and together we will march towards IIT. We will do that. We will crack this year. Okay, thank you.